Good morning, class 6. Let's continue with our chapter 13, Fun with Magnets. In our previous class, we have done about the poles of the magnet. Okay, and we have done about the magnetic and non-magnetic materials. So today we will start from finding directions. So all of you take out your science book and open page number 129. Finding directions 13.3. Let's see. Let's start. 13.3 Finding directions. As we all know that magnets helps us to find directions. Okay, now let's see how. Magnets were known to people from ancient times. Many properties of magnets were also known to them. You might have read many interesting stories about the uses of magnets. One such story is about an emperor in China named Huang Ti. It is said that he had a chariot with a statue of a lady that could rotate in any direction. It had an extended arm as if it was showing the way. The statue had an interesting property. It would rest in such a position that its extended arm always pointed towards south. By looking at the extended arm of the statue, the emperor was able to locate directions when he went to new places on his chariot. Let us make such a direction finder for ourselves. Activity 5. Take a bar magnet, put a mark on one of its ends for identification. Now tie a thread at the middle of the magnet so that you may suspend it from a wooden stand. Make sure that the magnet can rotate freely. Let it come to rest. Mark 2 points on the ground to show the position of the ends of the magnet when it comes to rest. Now, what it's saying? It says that from ancient times, magnets are known to find directions, and there are so many properties of magnets which are also known, like finding directions like this only. There are some other properties also of magnet which were known. Now there is an interesting story on this. Actually, there was an emperor. Emperor means a king. So there was an emperor in China whose name was Huang Ti, and it is said that he had a chariot. Chariot means tanga. So he had a chariot with a statue of lady, on which there was a statue of lady, as you can see on figure 13.8. Okay, so that has a statue of lady which rotates in any direction, which can rotate in any direction. Okay, now there was an extended arm. Now that statue lady or that statue has an extended arm for showing the way, as that extended arm shows the way. Now the statue had an interesting property. Yes, that statue has had an interesting property, like it would rest in such a position that its extended arm always pointed towards south. Now what happens that जो extended arm था, that always remains in the same position and it always points towards south. Okay. Now by looking at the extended arm of the statue, the emperor was able to locate directions when he went to new places. So whenever that emperor wants to go some new place, what he do? He go with that chariot only, because that statue helps him to locate the directions or the where he went. Now let's see activity 5. In this, what you have to do, you have to take a bar magnet and put a mark on one of its end. You have to put a mark on one of its end just for identification. Okay, after that tie a thread at the middle. After that you have to tie a thread at the middle of the magnet, as you can see in figure 13.9. You have to tie a thread at the middle of the magnet just to suspend it from a wood stand. Just to suspend it means just to hang it or keep away or just keep at some position or distance from a wooden stand. Okay, now make sure that the magnet can rotate freely. You have to be sure that magnet is able to move freely. Okay, now let it come to rest. Now let the bar magnet come to rest. As when you will hang it, what will happen? That magnet will rotate. So you have to wait for the magnet to come at its rest position. Now mark 2 points on the ground to show the position of the ends of the magnet when it comes to rest. Now what you have to do, you have to mark 2 points on the ground just to show the position of the end. You have to mark 2 points on the ground just to show the position of the ends of two magnets when it comes to rest. You have to mark 2 points on the ground just to show the position of the end of the magnet. Okay, now see page number 130. Now draw a line joining the 2 points. This line shows the direction in which the magnet was pointing in its position of rest. Now rotate the magnet by gently pushing one end in any direction and let it come to rest. Again mark the position of the 2 ends in its position of rest. Does the magnet now point in a different direction? Rotate the magnet in other directions and note the final direction in which it comes to rest. Now what you have to do, you have to draw a line joining the 2 points. Okay, after that what does that line show? That line shows the direction in which that magnet was pointing when it was in its rest position. Okay, so then after marking the point or noting down the direction, again rotate the magnet gently just by pushing one end in any of the direction. Okay, again what will happen? After some time that bar magnet will come to at its rest position. Okay, again do the same thing. Mark the position of the 2 ends in its position of rest. After that what you will show? What you will observe? Does the magnet now point in a different direction? Rotate the magnet in other directions and note the final direction in which it comes to rest. Okay, now do this activity in other directions also by rotating the magnet in other directions also. What you will see? You will see that the bar magnet will always point into a particular direction. Okay, now do you find that the magnet always comes to rest in the same direction? Now can you guess the mystery behind the statue of the Emperor's chariot? Repeat this activity with an iron bar and a plastic or a wooden scale instead of a magnet. Do not use light objects for this activity and avoid doing it where there are currents of air. Do the other materials also always come to rest in the same direction? Now do this activity in other directions also. What you will find? You will find that the magnet will always show or it will come to rest at a particular direction only. Okay, it will rest in a particular direction only. Then repeat this activity with an iron bar or a plastic wooden scale. Yes, you can repeat this activity with an iron bar as well as a plastic or a wooden scale instead of magnet. Now, what you will observe? You will observe that they will give some other result, but the magnet will give the same result. Okay. Now, we find that a freely suspended bar magnet always comes to rest in a particular direction, which is the north-south direction. Okay. Now, the magnet will always come in a particular, it will rest or it will always rest in a particular direction only, which will be north-south direction. Okay. Now, use the direction of the rising sun in the morning to find out the rough direction towards east where you are doing this experiment. Okay, now you can use the direction of a rising sun also where you are going to do this experiment, because sun rises in the east. That's why that direction you can use. Okay, you can use for doing this experiment. Now, using the sun for finding directions, you may not be very exact. Now, for sun, your directions or your observations cannot be exact, or they can vary, but it will help to make out the direction north from the south. Yes, but as using sun for finding directions, you can't find out, but the magnets can help you to find out the direction from north to south. Okay, now using this you can figure out which end of the magnet is pointed to the north and which point is at the south. The end of the magnet that points towards north is called its north seeking end, or the north pole of the magnet. Now, the end of the magnet or the pole of a magnet which shows towards north, which points towards north, that is called north seeking end, or the north pole of the magnet. Okay, and the other end which points towards the south, that is called south seeking end, or the south pole of the magnet. Always magnets have two poles, whatever their shape may be. Usually north and south poles are marked on the magnet. Yes, as I told you in our previous class that there are two poles of magnet. Okay, the first one was the north pole and the second one was south pole. So all the magnets, all type of magnets, either a ball shaped, a bar, or any other type, they all have two poles, north and south. This property of the magnet is very useful for us. For centuries, travelers have been making use for this property of magnets to find directions. It is said that in olden days, travelers used to find directions by suspending natural magnets with a thread which they always carried with them. No. Yes, the finding direction property is really very helpful for the pupil or for us, because it helps us to find directions. Okay. Now, it is used from the centuries. For centuries also, in the centuries also, travelers use this technique. Okay, they use magnets just to find directions of their way. Later on, a device was developed based on this property of magnets. It is known as the compass. A compass is usually a small box with a glass cover on it. A magnetized needle is pivoted inside the box, which can rotate freely. The compass also has a dial. Now, later on what happened? A device was developed which was known as compass. So compass has all the properties. A compass have all the properties of a magnet. How? It uh, it uh, it is usually a small box which is covered with a glass. Okay, and there is a magnetized needle which is pivoted inside the box. Okay, so in that box, what happens, that magnetized needle can rotate freely. Okay, and that compass has a dial with directions marked on it. And uh, we all have watches. Okay, and we all have seen a watch also. What happens in what is there on that dial? There are numbers on a watch dial, but in compass what happens, there are directions. The directions are written on that compass dial. Okay, now see page number 131. When this device was developed, what happens, that compass is kept at the place where we wish to know the directions. Now people start using compass just to find out the direction or their way wherever they want. Okay, now its needle indicates the north-south direction when it comes to rest. Now the needle of the compass that indicates the north-south direction whenever it comes to at its rest position, and the compass is then rotated until the north and south marked on the dial are at the two ends of the needle. Now and after that the compass is rotated until and unless the north and south directions marked on the dial are at two ends. Okay. Now to identify the north pole of the magnetic needle, it is usually painted in a different color. Yes, just to identify the north pole of the magnetic needle, it is usually painted from different colors. Okay, basically you will see that the north pole or the needle marked with red color paint. Okay, now 13.4, make your own magnet. There are several methods of making magnets. Let us learn the simplest one. Take a rectangular piece of iron, place it on the table. Now take a bar magnet and place one of its poles near one edge of the bar of iron without lifting the bar magnet. Move it along the length of the bar till you reach the other end. Now lift the magnet and bring the pole to the same point of the iron bar from which you begin. Move the magnet again along the iron bar in the same direction as you did before. Repeat this process about 30 to 40 times. Bring a pin or some iron fillings near the iron bar to check whether it has become a magnet. If not, continue the process for some more time. Remember that the pole of the magnet and the direction of its movement should not change. You can also use an iron nail, a needle or a blade and convert them into a magnet. You know how to make a magnet? Would you like to make your own compass? Now, what you have to do? Yes, we can make our own magnets also, just by several methods. Okay, there are some methods for making our own magnet. Now, let's learn the simplest one. Now what we have to do, we have to take a rectangular piece of iron and that iron, we have to place it on a table. Okay, and after that take a bar magnet and place one of its end near one edge of the bar of iron. Now what you have to do, you have to take a bar magnet and place one of its pole near one edge of the iron, near the edge of the bar of iron, and without lifting the bar magnet, without lifting that bar magnet, move it along with the length of that bar magnet. Now without lifting means you have to not lift up the bar magnet, you have to move that magnet along with the length of the iron bar, okay, till you reach the other end. Now lift the magnet and bring the pole to the same point of the iron bar from which you begin. You can say this like scrabbing, as you all do scrabbing from one point to second point to the another point, like that only, from north to south, and again south to north, again north to south. So you have to do like that only. You have to lift that bar magnet along with the length of the iron bar. Okay, now lift the magnet. Now move the magnet again along the iron bar in the same direction as you did before. Now again you have to do it same with another pole. With the same with the same pole only, not with another pole. The same pole, you have to move that magnet in the same direction. Now you have to repeat how many times you have to do this process. You have to do this process just for 30 to 40 times. Okay, and after that bring some iron pins or iron fillings near to that iron bar, just to check that it has become a magnet or not. Okay, now when that when you will do this process for 30 to 40 times, what will happen? The properties of that magnet will somewhat come to the iron bar also. Okay, and when you will bring some iron fillings closer to the iron bar, what will happen? If that iron has gained the property of a magnet, अगर iron जो iron bar हमने रखा था iron scale, अगर उसमें magnet की properties आ जाएंगी, okay, then what will happen? That will attract the iron fillings or pen, okay, which will prove that that iron bar has become a magnet. And if it does not attract, then what you have to do? You have to continue that process for some more time. Now remember that the pole of the magnet and the direction of its movement should not change. Now you have to remember that the pole of the magnet, and suppose we have started doing this process from the north pole, okay, so you have to do that process in the north pole only, and the direction, suppose north to south, so it should be north to south only, not south to north. Okay, it should be in the same direction, as well as the pole of the magnet should be also same. Okay, because if you will change the pole or the direction, what will happen? The properties will lose, or the iron fillings or the pins will not attract to the iron bar. Okay, now you can use an iron nail, a needle or a blade and convert them into a magnet. Now you know how to make a magnet. Would you like to make your own compass? Now you know how to make our own magnet. Now are you wishing to make your own compass? Let's see activity 6. Magnetize an iron needle using a bar magnet. Now what you have to do? You have to magnetize an iron needle using a bar magnet, as we have done right now. Okay, like that only you have to magnetize the iron needle. Now insert the magnetized needle through a small piece of cork or foam. Now what is a cork? Cork is used just to close the bottle openings. Okay. So you have to insert that magnetized needle through a cork or foam. Now let the cork float in water in a bowl or a tub, and let that cork float in water in a bowl or in a tub. Because and how it will float? Because the weight of a cork is very low. Okay, that's why it will float in water. Now after this, make sure that the needle does not touch the water. Now you have to be sure that needle should not touch the water. Your compass is now ready to work. Now your compass is ready to work, as you can see in figure 13.12. Make a note of the direction in which a needle points when the cork is floating. Now, after preparing a compass, you have to note down the directions in which needle points. Okay, when that cork rotates. Now rotate the cork with the needle fixed in it. Now what you have to do, you have to rotate that cork with the needle in different directions and note down the directions in which needle points. When the cork begins to float again without rotating, does the needle always point the same direction? When the cork stops rotating, now yes, it will rest at the same position, which will be north to south. Now after that, 13.5, attraction and repulsion between magnets. Let us play another interesting game with magnets. Take two small toy cars and label them A and B. Place a bar magnet on top of each car along its length and fix them with rubber bands. Now, yes, attraction and repulsion between magnets is also a property of a magnet. Okay, in this you will see that how two poles attract each other and two same poles attract each other and two different poles repel. They show repulsion. How two different poles show repulsion. Okay. Now see page. Turn to the page 132. Now in car A, keep the south pole of the magnet towards its front. Place the magnet in opposite direction in car B. Now place the two cars close to one another. What do you observe? Do the cars remain at their places? Do the cars run away from each other? Do they move towards each other and collide? Now, what you have to do, you have to take four cars, some small toy cars, and you have to place a magnet in different directions. Okay. Now in car A, you have to keep the south pole towards the front, and in B, car B, you have to place a magnet facing front will be south. What you will observe? You will observe that they both will not attract to each other. It will show repulsion. Okay, so they remains at their same place and they try to run away from each other, but they will not run, but they will remain at their same places only. Okay, they will not move towards each other as well as they will not collide with each other, because north and south will not attract to each other. North and north will attract each other, but north and south will not attract to each other. South to south will attract, north to north will attract, but north and south or south and north will not attract. Record your observations in the table as shown in figure table 13.3. Now place the toy cars close to each other such that the rear side of the car A faces from the front side of car B. Do they move as before? Note the direction in which the cars move now. Next, place the car A behind car B and note that the direction in which they move in each case. Repeat the activity by placing cars with their rear sides facing each other. Record your observations in each case. What do we find from this activity? Do the similar poles attract or repel each other? Yes, two similar poles attract each other and two different poles repel each other. What about opposite poles? Do they attract or repel each other? Opposite poles repel each other and similar poles attract each other. This property of the magnets can also be observed by suspending a magnet and bringing one by one the poles of another magnet near it. Now, this property of the magnet can be observed just by suspending a magnet and bringing one by one the poles of another magnet near to the first. Now, a few cautions. Magnets lose their properties if they are heated, hammered or dropped from some height. Also, magnets become weak if they are not stored properly. To keep them safe, bar magnets should be kept in pairs with their unlike poles of the same side. Now, yes, as magnets are very useful, they need some care also, because if we will heat up the magnet or we will hammered or the magnets will be hammered or dropped from some height, what will happen? They will lose their properties. Okay, and that magnets will become weak if they are not stored properly. Okay, now just to keep our magnets safe, let's see what is given in on page number 133.